Welcome to the Structural Engineering Podcast. My name is Max.
And I'm Zach.
And this week we're talking about slabs. Slabs pretty much on the ground. We're not, maybe a little bit elevated.
Now, are we talking concrete or that cast-in-place steel?
No, this one's all concrete. You may have seen it in a building. It's in almost every one. I was going to look this up earlier, so I'm hoping you know. I feel like slab on grade is the cause of a lot of lawsuits.
Yeah.
Do you know how many?
I do not know how many, but I would say with our last conversation about, lawsuits and stuff like that, it sounds like slab on grades and foundations are like the number one thing with lawsuits.
All right, maybe we're wrong on that one. I spent a long time trying to find this information, but had no luck. It seems there's 100 things you might get sued for before a slab on grade becomes the one, but it's still something people care a lot about, especially in the industrial space. So it's important to know how to do it right and what could go wrong. Slabs, concrete cracks, right? And when we have exposed concrete, often the client, expects it to look like it's fresh, polished condition, and that's not always going to be the case. So I think expectations of what a slab looks like is really important to discuss with a client right off the bat. Do you, Zach, what do you use? You do a lot of offices and stuff. What's that slab?
I'm typically a 4 or 5 inch slab. I've got some clients that like the 4, and it's interesting. There's some architects out there very opinionated on their slab on grade thickness.
What do they think that 5 does over 4 when we're talking office slab, no loads, light loads?
So typically the 5 inch slabs that I've been, specifying, that client specifically does not cut their slabs at all. They pour it. They don't do any admixtures for anything for preventing plastic shrinkage cracks. They think with 5 inches, they just get a better floor. They typically just carpet it, something like that. It's not usually exposed. And I'm not more. I don't know more than that of why they like to go 5. But no matter how much I say 4, they say 5. So I don't even ask anymore.
I mean, they're onto something, right? A thicker slab can go farther between saw cuts, control joints. But if they're not doing any control joints, I don't know if it matters all that much. Are you reinforcing it?
Yes.
How much? What percentage?
The same percentage I've done every single project, and I checked once to know if it met minimum reinforcing. So I think it's 0.0018.
But minimum to what? Why 1/8?
Because that's what the code tells me to use, Max.
It's not a structure. It's a nothing.
Just for shrinkage.
For shrinkage, okay.
To prevent shrinkage. So it's my temperature steel.
I got some thoughts there. I think so I was at World of Concrete a couple weeks ago, and I went to some good presentations on this. But we'll come back around to that percentage in a little bit. I saw a great presentation by Tyler Lay, who will be on the podcast in a few months. But many people might know him on his YouTube. He does some really cool concrete videos. And then a bunch of other people, Jerry Holland, Kim Basham, people that just love slabs just more than you could imagine. And it's cool to just dig on something that hard. I'm going to start my monologue for a second on the way Tyler Lay started his presentation, because I thought it sets some nice context here. So imagine, if you will, just for a second, a 1-inch tube of concrete. Just, close those eyes. 1-inch thick concrete. How much can that thing hold in compression? It's just, 4,000 PSI concrete. Just picture an object. Is it a person? Is it a house? What do you think, Zach?
I'm going to say it's a car.
Oh, you're good. A 2019 Toyota Corolla weighs 3,000 pounds. That thing will fit. Right, yep. That'll fit. A 1-inch. That's so small. 1 inch will hold up a car. Let's flip it upside down. Now something's hanging from that same little cylinder. What can I hold?
Ooh, I'm going to say 10 pounds.
10 pounds.
Intention?
You want to do it as like, what do you, a house plant?
Ooh.
Give me the visual.
I'm going to say this can hold 7 LaCroix. taped in
it's about
series.
A gallon, maybe 8 pounds. It could hold a heavy dude. It could hold 300 pounds.
Big boy.
Yeah, you get about a 10th ballpark of your compression value and tension. So you're going from 3,000 pounds to about 300 pounds. Big guy. Now, let's throw in a piece of rebar, right? That same cylinder, we throw in one number 4 tiny piece of rebar. What's that thing going to hold?
Tension or compression?
Tension.
Ooh. Now 3,000 pounds is holding the car.
Oh, it's easily holding the car. It's holding so much more than the car, right? Yep. We're going to be
have the concrete range.
Oh, yeah. Concrete's, it doesn't matter. Concrete's just hanging out now, right? You could throw 10 more heavy guys on there. You got 11 heavy guys, and the concrete, you won't even see the crack, right? That's so small, it's 0.003 inches. There's a crack. Concrete is done with its tension, but you can't even see it. You could throw 40 heavy dudes on there, and the crack will only be half a fingernail. 40, that's 12,000 pounds. After that point, your rebar's yielding, and the crack gets big quick. But it'll go for a while, right? Because steel's pretty ductile. That piece of rebar will stretch for quite a ways. A distance of half its diameter or more at least. So you've got a ways to go. Now, the other little this piece of this, whatever I'm talking about here, is when we have a beam. Let's just imagine a simply supported beam. We know now the only reason we need this rebar is for tension. So in our simply supported beam, where is the only tension? Well, it's at the bottom, right? Now imagine a piece of concrete laying on the ground. Where is the tension? What is you pour this concrete on, a stable sub base. There's nothing but people or whatever, something light walking around up top. Where is the tension?
In the concrete.
The tension's kind of everywhere, right? It's the tension is from the concrete itself. The tension is from the concrete shrinking, from the concrete curling, and all of these things are tied to shrinkage in the concrete. We have all these problems, right? It's like random cracking, joint widening, joint stability, curling, warping, spalling, and just joint filler performance. These are all shrinkage problems. So that's what we're up against, right? We have concrete, it's wet. About half the water that we put into concrete goes into hydrating the cement and making the concrete strong. The other half is just for workability. Concrete is going to shrink a ton. That shrinkage is the source of all of our concrete problems. All right, so now we know concrete shrinks, and that's its problem. But we will do what we can to avoid it. So, as you were saying, as it shrinks, it'll warp. That's a big problem. Our two biggest problems, I think: warping, restraint, shrinkage cracks on the surface of the concrete. When you do, Zach, if you do an office slab, or how much, if you've done a bunch of industrial, I don't think a lot of industrial slabs from our time working together. That was what I was jamming. What do you put underneath?
Usually there's some sort of sub base that gets placed down. Depends the kind of soils we're dealing with. Maybe they over excavate, come back with some nicer soils. Usually there's some sort of sub base, and then vapor barrier, and then you
do a vapor barrier.
Mm-hmm.
Always.
Yeah.
Man, that's good. That's awesome. That's not common. So there's this.
I don't know if I've done a project yet that has not in 6 years of my career.
There's this idea, which is debunked, that when you put plastic underneath the concrete, it won't dry. It'll dry unevenly and it will curl like crazy. Have you ever heard that? Oh, man.
No, I've never heard that ever. Yeah.
Yeah, that's the thing. The idea is that if you don't put some gravel subgrade underneath your concrete, you're going to get uneven drying because it's going to dry from the bottom. That is completely not true. So what I just said, that's not right. But that's what a lot of people think.
Now, is this misconception tossed around the construction side of things, or more the engineering side?
I think everybody.
Everybody. Okay.
It makes sense, sort of, if you think about it. Like, you're putting this wet thing on a piece of plastic. How could it possibly dry from below? But here's the thing. The humidity in the ground is always 100%, right? Did you do Boy Scouts at all? I got an analogy for you.
No, I didn't.
No? Okay, well, maybe you watch some survival videos or something. If you're in the desert, how do you get water? Do you you remember this wacky stuff?
Yeah, you dig a hole,
You dig a
you
hole.
put a piece of plastic over.
Yeah.
Yeah.
Even in the desert, the humidity in the ground is 100%. It's always 100%. And that's the whole thing with trying to dry your slab. This idea that if you put gravel down under your slab, and instead of doing this plastic barrier, it'll dry. It's not true because the ground is always 100% relative humidity. So instead of going from a water stop where moisture is allowed to go through your slab, you get this big gradient for a while, right? Moisture is moving up through your slab, but it's not adding any more. So you actually get far less curling if you have your slab poured directly on plastic, like you already do. So good job. But that is still kind of not everyone's doing that. We're not always doing that here, but I think it's a perception thing.
Yeah, whether it gets installed, I can't validate that, but I
Yeah.
know we either specify in our structural drawings, which I think is an interesting point because structurally it's not required. But I know majority of the time the architect or it's in the specs. So
Yeah.
I would say it's mostly there. If it gets installed or not,
Who
who
knows?
knows?
It's in your specs too, or is the architect like you just know he says vapor barrier, so you don't worry about it?
Yes. Yeah.
Okay, so it's not on the structure. You just say whatever, 4 or 5. Okay. There's another great thing about plastic, and that is shrinkage cracks are a big deal. If you pour a 20-foot square piece of concrete, you can expect that's going to shrink about 1/8 of an inch, which is, pretty decent. Enough to generate a lot of stresses in the concrete if it's really restrained. So really restrained is sitting on a bunch of really rough aggregate. If you have super coarse aggregate below, you've got a coefficient of friction of like 2, right? If you throw down a plastic strip, just one of them, you've got a coefficient of friction of about 0.7. If you do a double layer, you're going all the way down to 0.3. So the concrete can shrink, and there's just nothing in the way of it pulling in tight. There's far less strain in the concrete. You get way, way less shrinkage cracks. So that is a huge perk of using plastic sheets or double plastic sheets. I'll even throw in there, in the industrial world, there are these companies that will do sort of special slabs that they'll advertise that they don't do control joints for pretty long distance, and there's nothing wild in there, right? This is just pretty normal concrete with some admixtures. They do macro fiber and they do double layer of plastic. So that has a ton of room to shrink. The only thing with that sort of thing is you're still going to get, unless you're using maybe a shrinkage reducing admixture, you're still going to get a lot of that shrinkage. So instead of going 20 feet, if you're going 200 feet, you're going 1.25 inch shrinkage. That's got to show up somewhere. It's still real. It's going to happen. Whether that's at the wall, it's going to, be at the joint. So you still have to be careful. If you're doing these really big pours, shrinkage is still a thing that will happen. And you got to make sure that where it happens is an acceptable place.
So Max, we're talking about shrinkage. We're talking about curling, and all these things. Why does it matter to me?
It probably doesn't. I don't know if you meant to ask a very deep question, but do we own the slab? Is it the structural engineer's slab or the architect's slab or the owners? I mean, ultimately. But if it's not a structural slab, is it our responsibility to specify it? I think in many cases, not really. I think a lot of engineers defer to a very wishy-washy sort of spec on their slab. Control joints per ACI 360, just using those guidelines and kind of do whatever you need to, and that way it falls on the contractor. At the World of Concrete, when I was there, a lot of these guys presenting on slabs, they just kept pushing. Do not specify your slab, design it. Actually put in the effort to do it correctly, based on the loading that based on geometry, like going a little bit farther than a passive specification.
So let's say my slab shrinks, it does some cracking, maybe a little curling. What serviceability issues will the client have, or the owner of the building, or the tenant of the building have due to those issues, due to that?
Yeah. I mean, if you're looking at commercial structure, there's not a lot of serviceability issues, right? Cracks aren't a big deal unless you're doing polished concrete. you'll see them. That's for sure. One thing that'll happen though is if you're doing floor coverings, if the slab moves a lot, you could actually get at the joints. The slab will separate and then come back together and squish your flooring, and you'll see these lines coming down. So often when you see like, a compressed line of linoleum flooring down a concrete slab, that's the slab expanding, contracting, and pushing the floor back together. And that can be a real issue. That's a tripping hazard, I guess. But on a commercial, from a commercial standpoint, for the most part, it's not a big deal. There's not that much. People just don't like cracks, and I understand it. It goes back to the expectation point. I think it's one of these things that we should be discussing with clients, pre-design, pre-selecting the mixture. If they really want something that's less likely to crack, there are things you can do.
One thing I've been doing recently that's been working pretty good, and especially with slab on grades, is with design build work, asking the subcontractor, what mix have you poured previously that was successful?
Oh, yeah.
And working with them. And, the hard bid stuff, sure, you can't do it. You kind of write a generic thing typically that they can pour and it's going to be good. But when you can do design builds and have that conversation with the sub and say, okay, you've poured way more slabs than I have, which is 0. Well, I poured somebody's porch once, but that's what they do all day, every day. So why do we not lean on them as, an industry to say, hey, what slab design do you suggest? Sometimes it matters if it's slab on grade and it's got vehicle loading or something on there. Maybe there's a flexural strength that the concrete needs to have, or different requirements that the structural engineer is looking for. Maybe that slab on grade is acting with some structural capacity in more of a lateral instance. So maybe there's things we care about, but I find it really successful to ask them what do they want to pour and review that mix.
Yeah, I think that's a really good point. Something else I learned at this World of Concrete is that aggregate and the actual cement itself is very regional, and so you can get there. Different aggregates will actually swell different amounts, and so you can have these wide variations in different mixes. So if you're working in different markets, it's really worthwhile to just ask what is working there, and then apply that to what you're doing, what you know about slab design. But I wouldn't just go, take what worked in Utah and just say, hey, Seattle, we're doing this now. That's not going to work out well for you. So let's head back to rebar. So we hit it a little bit earlier, and you said you do the typical 0.018, so 1.8 or 0.18% steel. I have bad news for you. It's not ideal. It's actually what a lot of people in the industry call legal crete, if you know what I mean.
I don't know where you're going with this.
Yeah. Okay. Well, there's kind of 3 camps you can be in with these slabs on grade, right? If you're doing commercial, something where it is absolutely not a structural slab, you can do an unreinforced slab, right? If you have cracks, they will open up a little bit farther. You still have to do saw cuts and stuff. The other side of this would be a very small amount of steel. This is known as enhanced aggregate interlock. This is less than 0.1% area of steel. So if you have a 6-inch slab, this would be putting down number 3s at 18 inches on center, right? That's half of what ACI, like your minimum structural concrete, is going to be. And all that does is when your concrete shrinks, it's actually able to pull the rebar, and the rebar will yield a little bit and be able to separate at the slab, but the slab joint will still have interlock between the pieces of aggregate, so you can still have transfer over those joints. So instead of having a saw cut and it just goes straight through to your sub base, right, and then loads start going over the top of that, especially if you have a loading scenario, even if it's light, cars or whatever going over the top, those things are going to start to settle back and forth. It only takes 0.001 inches, a very, very small number, to start busting out your slab edge, to damage forklift wheels, these little tiny metal or plastic wheels. So you really want those things to be aligned perfectly. So this 0.1% will give you this nice aggregate interlock. Your steel will be engaged, but it won't be too much to restrain the slab from shrinking. One thing that's an issue with a lot of steel, but it can be acceptable, is if you put down a ton of steel, the slab will not shrink, right? It's so restrained by all this rebar, it just can't go anywhere. So it's going to crack like crazy. It's going to crack every 3 to 5 feet. You're going to see these little hairline cracks, but they are going to be held so tight that you don't even have to worry about it. This is kind of my preferred slab right now, because if you have an owner that's willing to accept that their floor is going to look like a spider web, you can say that there will not be any separation. You actually don't even have to saw cut this. You could go 125 feet and just have these giant, cracked, smooth slabs. You won't be able to feel them, and from an aerial view, you won't even see them. Okay, so ACI 360, right? That's our code, or that's our guideline, right? There's no code. If our slab is not structural, there's no minimum shrinkage temperature. There's no, specific thing we have to follow at all. And that's why you can get away with unreinforced. You can over reinforce it if you really want to. There's this awesome table called Table 2.1, General Comparison of Slab Types, in ACI 360, which you could probably find online for free, I'm pretty sure. And it tells you the types that are around. So we hit a lot of them. Unreinforced. All right, they say like, oh, it's simple to construct, it costs less to install, but disadvantages: requires relatively closely spaced saw cut joints, more opportunity for slab curl, large number of joints. So going down the list a little bit more, we can reinforce with deform bars or welded wire reinforced sheets just for crack width control. That is the aggregate interlock that I'm pushing. That's my second favorite, right? And so the advantages there: saw cut contraction joint spacing can be farther apart. Reinforcement is used to limit the crack width, but it still allows it to crack. But it may reduce long-term flatness of the slab. So this is like way out. Concrete will dry for a year and a half, right? Disadvantages: reinforcement can actually increase the number of random cracks, which is what we're saying for the high reinforcing. Once you get a lot, I mean, it will really throw them everywhere. And then positive load transfer may be required at the joint, something a little more than the reinforcing. You could do a continuously reinforced slab, and we already hit it, but the benefit there, you could just remove saw cut joints. Disadvantages, though, requires relatively heavy reinforcing, that 0.5%. That's like 2.5 times what we usually think of as like the minimum for any structural slab, and you'll have a ton of cracks everywhere. I just like this one because it feels like it's very consistent results, and it's still structural. We haven't really hit on like the difference in structural. Are you putting stuff on slabs often? Structures?
I wouldn't say very often. Nothing that's too heavy typically.
What to you, like, why do you have to go to something you'd call a structural slab? What would separate that from a non-structural, unreinforced,
The first thing that comes to mind really would be something like most sidewalks are unreinforced concrete.
Oh yeah.
And so to me, it's like the loading that a sidewalk sees, I would agree that it's a slab on grade would be. So light loads, maybe some vehicle load, like light vehicle loading. I'm chasing, going to a structural slab with like, definitely I've done a couple warehouses where they've got huge racking systems that put pretty good point loads, very concentrated point loads on the slab. And I kind of go to a thicker structural slab that's got a lot more reinforcing in it. And, I'm not just reinforcing for the shrinkage. Sometimes it's thick enough to where it has 2 mats of reinforcing.
Holy cow.
For some pretty crazy equipment in kind of the crazy heavy industrial world. I've done a couple. But I would say everything I have more or less experience with is a slab to be there. You know what I mean? Like it's holding carpet up and people and desks.
So my idea of structural is a little bit different.
If you were to cut the slab out, is the building still structurally sound?
Yes. Oh yeah.
So that would define. That's probably my thinking now, how I would define if it was structural slab or not. Not necessarily defining the thickness or what the loading is, but is it required for the structure to be
and
in a stable
would say
condition?
If you can, if you're throwing heavy loads on a slab, you still don't need to be, you could have a warehouse type structure with a bunch of heavy loads, and you can be that 0.1% reinforcing. That's not structural. That's not going to serve as a diaphragm. You can't put a mezzanine up with some columns sticking on that, but you can put racking, right? So when you don't need to go, rebar is expensive. What's it, $5,000 a ton? I think if you don't need to use it, you could save a lot of money by not using it.
One thing I think about a lot with slab on grades, structurally, there's a lot of benefit to tying things to it. Like you said, site class F with liquefaction, tying the building together is great. I've seen people tie the slabs to foundations for sliding issues, tie slabs for multiple different types of things. But to me, the biggest issue is tying slabs to the structure. Most people don't think that's a structural element. They will come back, they'll cut it out, they'll come back, they'll pour something else. Now maybe your hairpins that are holding your column in place are cut out and are gone. I mean, like you said, using a tie beam is key, especially to those things. It's like, what's the future use? And something I've learned recently is, even if the owner is like, okay, no problem, tie it all together, we'll just make sure we never cut it. What about the next person?
Yeah.
And we're liable for that building for way longer than that owner. So I think as an industry, we need to push back more of like, okay, I get you want to do this cheaper, better, or cheaper, usually less, but in the future, this could be an actual issue, like truly. And I think really, if you're throwing massive loads to your slab, probably do something different.
I don't know. I don't totally agree. I think if you had an office slab or something weird where it happened to be structural, and maybe that's tying columns, right? These people should be probably engaging a structural engineer before cutting into these things. And if you have the contract drawings, which they will have, that comes with a building, it has to be per IBC. It has to be clearly stated that it's a structural slab. So yeah, I could see down the line it's forgotten. Someone just goes wild and cuts a slab and puts in a swimming pool. But I think it's a perfectly valid. I don't know. I think it's a perfectly valid structural system, and in many cases, it's cheaper and better. I mean, if we're looking at large warehouses, using the slab as the diaphragm saves a ton on foundation and is actually just easier to construct. It's better in a lot of ways.
Sure. Yeah. I think it really depends on what the structure is, the use, the future. Thinking through it, I definitely read some case studies where people came in, cut out the whole slab, just filled it with gravel, and the building started moving quite a bit. There's a bunch of different things.
You come in and you throw cut a little hole in the floor and throw an elevator, and you actually just cut the core to the building, and you didn't really think about it. Like, I think putting a hole there is just as reasonable and unreasonable as throwing a hole in the slab. But
I would say throwing a hole in an elevated slab is what I'm guessing you're thinking of, or you're still thinking so. Yeah.
No, elevated. Yeah. You just, I need a little staircase here. No big deal.
My own experience, that people perceive that to be a much bigger deal than cutting holes in the slab on grade. We'll share to the Structure magazine that they strongly urge against it too.
What is their argument? That you shouldn't use it as a structural slab?
If you use it as a structural slab, it needs to be designed as a complete diaphragm per code. And their drive from that is there's a little bit in here too, talking about that it can become an issue with that whole thing of like, do people know that this is a slab that's structural? And I've seen where it's really like certain slabs have been really important. Maybe it's going to be covered up with carpet or something. I have seen projects where they've like spray painted on it structural slab, then covered it up with carpet. So if anyone were to, take the carpet off, they would see what are all these yellow stripes that say structural slab, do not remove, or stuff like that. So
that's a very good idea.
And the article goes through saying it is the cheapest, but also the most problematic solution to rely on hairpin ties in slab on grades. They're mostly driving towards, in this article, that nobody designs their slab on grade as a concrete diaphragm, cords and collectors.
Well, that's their problem.
Driving pieces.
They should be. That's important.
Yeah, but it'd be interesting if you're listening to this. Let us know publicly or send us an email. It'd be interesting to know if you're using your slab for any sort of reason. Let's say it's a 4-inch slab. Are you analyzing? Are you looking at it? Or you just kind of assume it works?
Let's hit on fiber really quick. Have you used macrofiber?
Yeah.
Have you used microfiber?
I don't recall. Usually I get something from the concrete sub that says, here's what we want to use. We like it. It works well. Sometimes those have some issues finishing, but that's a different topic.
Yeah.
Same topic. We're on concrete. We're not trying to make it look pretty.
What is microfiber for?
Tension.
No. Microfiber's just really not for anything. It's for plastic shrinkage cracks. It's for
holds it together.
Early on, holds it together. Macrofiber.
So it takes tension.
Yes.
Because it can't take compression, so it.
Okay.
Just for the record, in case you're ever quizzed on this, what's really happening with the microfibers is they're serving as a conduit. The plastic shrinkage cracks occur because the top layer is drying quicker than the bottom. So the microfibers act as a little conduit to get some of that water that's sitting down below the surface and bring it up to the top to keep that hydrated. But yeah, they could only take tension too.
Macrofiber is your good one. Microfiber is, you're looking at a 1/2 inch to maybe up to 1.5 inches in length. You're doing little small dosages past that plastic shrinkage cracks early on. It's just not doing anything for you. Macrofiber is the heavy hitter. That's, at least 1.5 inches long, maybe up to 2 inches. Tons of dosage, like 3 pounds, 6 pounds per cubic yard of concrete. There was a cool study that one of these guys did, and they were looking at the effect of macrofiber, how much the dosage, and the crack width. So the one takeaway that I'm just going to hit real quick and we'll move on is that going up a lot doesn't add very much, especially in your service level cracks. If you are pulling your slab apart, 12 pounds of macrofiber will hold it together longer. But if you're not picking your slab up and ripping it to pieces, like King Kong or something, 3 pounds to 6 pounds is perfectly fine. Do not let the salesman tell you that you need 12 pounds or whatever it is. 3 to 6. And 6 is not twice as good as 3. 12 is not 4 times. It's like 6 is maybe 25% better. Okay, the last thing that I wanted to hit is knowing how much shrinkage your concrete has. Because if you have that number, you know how far apart your joints should be. You know what kind of trouble you're looking like you might get into. Have you ever heard of ASTM 157?
I can't say I have.
Yeah, I don't know. I wrote it down here, though, and it is what gives you the shrinkage potential of your concrete. It can be a long test. I think it's up to 72 or 64 weeks, but it doesn't have to be that long. One of the guys that was giving these presentations, he said you can get it done in 28 days. You can get a perfectly reasonable estimation. So your concrete shrinkage curve, it starts to drop off steep, right? It is just shrinking super fast, and that first 7 days is just plummeting, and then it starts to level out, and it tapers down for a pretty long time. The ASTM 157, that'll follow that taper for a while. You'll know for sure. It is a crazy test. You make a block of concrete, you wet cure it for a day, or in a humid environment. Then you put it in a lime bath for 28 days. I don't think it's the squeeze of lime in a little kind of umbrella. I think it's the other one. Then you pull it out and you just start measuring it. You cast in these little anchor points and you put it in a machine that tells you its length, and you go forever and ever and ever. It's unreasonable for normal mixtures, especially if you want to try something new. You just won't be able to get it done before your slab is poured. So you can do a shorter version. There's a guy, Scott Tarr, and he's got some good articles in structure and everything, talking about what you can do to get your shrinkage potential. And then in ACI 360, there's a nice graph. This is if you have a high shrinkage concrete, you need to have control joints at this ratio. You're capped 15 feet if you're a high shrinkage concrete. And that's why a lot of general notes, I think, will just cut off their slabs. Can't be longer than 15 feet, right? The ratio length is 1.5. Some will go down to 1.25. to 1 is your ratio. 15 feet is the farthest length. That covers, for the most part, high shrinkage concrete cracks if you're thick enough. There's also the caveat of 30 times your slab thickness, or maybe some people tone that down even a little bit more. If you have a low shrinkage concrete, you can get away with way farther. There's just no reason. It's expensive to cut slab joints. If you have a warehouse that's 1,000 feet long and 500 feet tall, these guys will be walking miles before they're done cutting your joints. So if you cut that out, it's a better slab, better for everybody.
Yeah, I've seen some interesting admixtures come across the desk promising no shrinkage, massive slabs. And
are they shrinkage reducing admixtures? Like, that's what they're billed as?
More or less, yeah. They say they reduce shrinkage, but they're what is the term I'm looking for? They're very high consolidating mixes. They're usually like a very high slump. What I'm trying to get to is there's a lot of people, I think, selling some things out there in the world
Witchcraft.
that are completely witchcraft.
There is
crap.
Okay, so, witchcraft. Yeah,
there's been a couple admixtures I've gotten definitely that have made slabs look pretty nice.
Well, okay, so there are shrinkage reducing admixtures, and they're legit. They're expensive, but they can work if you've got. There are regions of the country where all the aggregate you get is going to be really high shrinking aggregate, and the cement mix that you get, like your local, they don't ship aggregate across the country. It's super heavy. So you can use, and it might be reasonable in your area to use SRAs. What they do is in those first 7 days, they actually make the concrete expand a little bit. So you get the opposite. Whatever the opposite of curling is, you get bowing. I don't know. And so then it starts to come back down. The shrinkage, the shrinkage is the water leaving. It's going to happen for sure. But if you have that initial expansion, their goal is to actually just come back to where you started. So if you started flat, you'll bow out, you'll get a bigger floor, and then you won't see it. It's not that big. But, then it'll come back down and it'll come back to flat. So it's a reasonable option. It's very expensive.
Yeah, I think the one sales pitch I watched on it, they were saying you could do nothing around your columns and you can just pour the concrete right up to it and it will never crack. That was their whole sales pitch. Never crack, Max. Now, will they sign a piece of paper that says that? Probably not, but it's an interesting conversation.
There's some other cool tables that I've been digging up here. And this one separates everything that goes into what makes a slab shrink and gives it a relative shrinkage potential. I didn't really understand reading this graph. It goes up to 700%. I'm not going to read them all. I don't know how you get to 700%, but I think it does give a good relative value between them, right? So they're saying that, the temperature of concrete when you pour contributes 8% to the shrinkage potential. That's the lowest number on this list. We're starting at 8. And that is if you pour a really hot slab, it's starting very big, right? If you pour a cold slab, just thermal, it's going to be smaller. If you have a high slump mix, we're going up to, that's a 10% contributor. Higher slump is going to be worse. That might be because it has a higher water cement ratio. The more cement and the more water, the worse you are. Time in the mixture, I don't know about that one, but apparently if you go for a long drive, maybe it starts to set, that's going to be 10% contributor. Small aggregate is also a problem. You really want the biggest aggregate you can get and a wide gradation. There are some great resources out there for any actual mixture designers. It's called a tarantula curve. And you have these two peaks of where you want your aggregate passing. So you want, to push the biggest rock you can, 1.5 inches, even bigger in an unreinforced slab. Dirty aggregate is another contributor. That can be a huge problem. That's like 25% of your shrinkage potential can come from just junk in your aggregate. And then the aggregate being high shrinkage can be a 50% contributor to your total shrinkage, and cement 15%. So those are the ones I pulled out of the table that I thought the most interesting. Aggregate shrinkage is actually a pretty major contributor to your total shrinkage. So if you can get that lower shrinkage aggregate, if you're doing a fancy slab and they really want it to be flat, it might be worthwhile.
So from where we start to now, I would think most listeners, and myself definitely, there's a lot more that needs to go into the design of the slab on grade than I think anyone would have thought.
Yeah, I took that away from the World of Concrete, was that I thought there was just gonna be like, hey, can I just have the answer and then I'll put that. I don't think there is just the answer, which kind of makes it fun. There are people that make their career out of it, like we said, and that sounds extremely boring. But people do it. Hey, maybe I'll do it. I don't know. Well, I say print out ACI 360, bring it to your manager, slam it on their desk. Hey, one last trivia. How deep do you cut your control joints in a slab?
Thank you for joining us this week in the Structural Engineering Podcast.
Please see the general notes, and we will see you in the next couple weeks.
Probably the best episode we've ever done.